Very good morning, students.
Good morning, sir.
Good
Good
morning,
morning,
sir.
sir.
Good morning, sir.
Good morning, everyone. Yes, let us start the discussion without wasting any time. Last class we have been seen about the micelle formation mechanism and all, and why do soaps not work in hot water? Because hot water has Ca+2 and Mg+2 ions. They will be forming the respective insoluble salts. And this was a mechanistic approach of the micelle formation as well. Now, if you go to the next concept, synthetic detergents. Synthetic detergents used in both soft and hard water as they give foam even in hard water. Synthetic detergents are cleansing agents which have all the properties of soaps, but which actually do not contain any soap. They will not be containing any soap, rather they will be having all the properties of the soap. If you look at the synthetic detergents, and some of the detergents will be giving foam even in ice cold water. Some of the synthetic detergents, they give foam even in the ice cold water also. So that's how they are going to be present. Yes or no? That is the mechanistic approach of the respective synthetic detergents. Like if you go with the different classifications of synthetic detergents, they are classified as anionic detergents, cationic detergents, as well as non-ionic detergents. So if you go with the anionic detergents are sodium salts of sulfonated long chain alcohols or hydrocarbons. Anionic detergents are sodium salts of sulfonated long chain alcohols or hydrocarbon. Let us take an alcohol, long chain alcohol like lauryl alcohol. CH3, CH2 they contain CH2H. This alcohol is treated with H2S4 to form lauryl hydrogen sulfate, which will be reacting with NaOH to form respective salt. And what was the mechanistic approach? Let us consider this total group is to be R dash group. So R dash OH is there, alcohol. R dash OH is treated with H2SO4. H2SO produce H plus ion. Lone pair of electrons and oxygen, they attack the H plus ion. As soon as they attack H plus, you will form R dash. R dash and oxygen will be having only one lone pair now, two OH bonds and a positive charge. We do have HSO4 minus in the reaction mixture because H2SO4 dissociates to produce H plus ion and HSO4 minus ion. HSO4 minus will be having the structure like this: S double bond O, S double bond O, OH and O minus. This HSO4 minus will try to attack this particular alkyl group, generating R dash O, S double bond O, S double bond O, OH. This is nothing but your lauryl hydrogen sulfate. This lauryl hydrogen sulfate, whenever it is added with NaOH, here still we have OH bond. So this OH bond can be cleaved. So OH minus can pick up this proton, and here O minus can pick up the or develop new electrostatic force of attraction with Na plus, forming R dash O, S double bond O, S double bond O, O minus, Na plus ion. This is nothing but sodium lauryl sulfate, which is an anionic detergent. Why we call this as anionic detergents? Because we have R dash O, S double bond O, S double bond O, O minus. The long chain alkyl group is connected to some anionic part. That is why the name anionic detergent. Is that clear?
Yes, sir.
Yes, right. Very good. So similarly, we have another system like dodecyl benzene. Dodecyl benzene, whenever you treat with H2S4, what is going to happen? If you think logically, earlier we have an alcohol acid reaction, acid base reaction occurred, and then we have nucleophilic attack. Then the lauryl hydrogen sulfated, that has been treated with a base, so that again OH bond can be cleaved. Ultimately obtained the anionic detergents. Now if you think of this dodecyl benzene treated with H2S4 forms respective dodecyl benzene sulfonic acid. And what type of reaction is this? First step, it is an electrophilic substitution reaction or not? Electrophilic substitution reaction. Electrophilic substitution reaction. as H2S4 produces H plus and HSO4 minus ion. That means from here the electrophile generated can be SO3 as well. And that SO3 is going to be attacked here, forming SO3H. So since the alkyl group is electron donating group, it will be ortho para directing. Among ortho and para positions, the para position is going to be occupied by SO3H. So we'll get dodecyl benzene sulfonic acid. Again, you have SO3H means S double bond O. S double bond OH group is there. So this OH bond can be again cleaved whenever you treat with NaOH. Here you are going to have CH3, CH2 taken 11 times, C6H4, SO3 minus Na plus. Again, we have the long chain hydrocarbon connected to anionic part. So it is also called as anionic detergent. This is also belonging to anionic detergent. Anionic detergent. And anion that is effective in the cleansing action. Anion is effective in the cleansing action because that is going to be developing, that will be forming the micelle around the respective dirt molecule, and that anion is going to be developing electrostatic force of attraction with water, polar water. That is how this is effective in removing the dirt, and that is, since anion is effective in removing the dirt, that is called as anionic detergent, right? Similarly, we have cationic detergents. Cationic detergents are quaternary ammonium salts of amines with acetates, chlorides, or bromides as anions. Cationic part possesses a long hydrocarbon chain and a positive charge on nitrogen atom. They possess a long hydrocarbon chain and a positive charge on nitrogen atom, and hence these are said to be cationic detergents. Like we can take cetyl trimethyl ammonium bromide. Earlier we have anionic detergents. In that anionic detergents, we have the hydrocarbon chain connected to a anionic system. But now what you are going to have is the cationic system is going to present. And in that category, you will be having quaternary ammonium salts. They are connected to some long hydrocarbons, and the positive charge on the ammonium salt, that is that will be developing new electrostatic force of attraction with respect to the halide ion. Cationic detergents have germicidal properties and are expensive. Therefore, they are of limited use. Cationic detergents have germicidal properties and are expensive, and that's why their usage is also limited because of cost effective properties and all. Cetyl trimethyl ammonium bromide, that was an example of cationic detergent. You have to remember that examples. CH3, CH2 taken 15, N, CH3 taken thrice with a nitrogen positive charge and Br minus. Cetyl trimethyl aluminum bromide, that was an example of respective cationic detergents. Is that clear, students?
Yes.
Yes, sir.
Yes, right. Very good. Non-ionic detergents. Non-ionic detergent means they do not contain any ion in their constitution. No ion is present. Liquid dishwashing detergents are non-ionic type. And you will be having mechanism of cleansing action of this type of detergent is same as that of soap. That is micelle formation only. Micelle formation. Mechanism of cleansing action of this type of detergents, that is also same as that of soap. These also remove grease and oil by micelle formation. Like whenever we have stearic acid reacting with the polyethylene glycol, in the stearic acid we have acidic group. In the acidic group and the alcoholic group, carboxylic acid and alcohol, they are going to be reacting in the acidic condition. So CO bond cleaves in the carboxylic acid, OH bond cleaves in the alcohol. So esterification happens. So you will get CH3, CH2 taken 16, C double bond O, ester is formed, and you have CH2, CH2, O taken n times, CH2, CH2H. It is nothing but some esterification reaction. Esterification. So here there was a no ionic species, so that is why it is called as a non-ionic detergents. And if you look carefully, if the hydrocarbon, whatever the stearic acid we have, if you take one more acid, or if the hydrocarbon whatever you are taking, if they are having high branch, if the hydrocarbons have high branches, then bacteria then cannot degrade. The degradation becomes difficult. The hydrocarbon has to be in the linear chain only. If with respect to increased branching, if we have more branching, what happens? If we have more branching, obviously the degradation process will become difficult and they are going to be acting as a pollutants. So we have to consider drawback. If hydrocarbon chain is highly branched, then bacteria cannot degrade this easily. So slow degradation of detergents leads to their accumulation, and they accumulate and be in the water bodies like rivers, ponds, and streams, and the water will also get polluted. Okay. These persist in the water even after sewage treatment and cause foaming in rivers, ponds, and streams, and their water gets polluted. So what you should consider? So higher branching means more the pollution. Detergents with a straight chain of hydrocarbons are preferred over branched chain, as the latter are non-biodegradable and consequently cause the environmental pollution. And we will be discussing about environmental pollution in the next section, that is next topic. Try to solve the example, students, all of you. What is the example?
Cetyl trimethyl ammonium.
Yes or no? Which of the following is a cationic detergent? Cetyl trimethyl ammonium bromide. That was the correct answer for this particular type of question. Okay, such type of theoretical question you can expect as far as the chemistry in everyday life, polymers, biomolecules has been considered. Right, so in the chemistry in everyday life, we have discussed about three chemistries, that is chemistry involved in the drugs and chemistry involved in the drugs as well as medicines, chemistry involved with the food materials, artificial sweeteners, food preservatives, antioxidants, and also we have discussed about chemistry involved in the cleansing action, the mechanism of micelle formation, cationic detergents, anionic detergents, and non-ionic detergents. Examples in every category you have to remember. And I think you all know what type of questions you will be expecting, and we have seen the examples as well. Right, students, now let us proceed with the next chapter named as environmental chemistry. So environmental chemistry. So whatever the activities we are performing in our day-to-day lives, as well as activities people are doing in the industries, because of all those activities, we are disturbing the environment, we are disturbing the ecosystem. Different types of gases which are produced, they are all going to be disturbing different kinds of environments and systems. So they all lead to the pollution. So in the previous days, like some 150 years back, you can see how the earth is, you can see how the glaciers are, you can see what the thickness of the ice present. And nowadays you can see how the drastic change has been happened. The earth was much colder earlier, like just 100 years. I'm not talking about thousands of years back. Thousands of years back, it was even colder. Okay, but nowadays, whatever the revolution we have made in the industry, in the technology, because of that, a lot of pollution has been created. I'm not saying that technology is useless and all. Technology is highly useful. It is changing our lives in a great way. It has a great impact on every human being. But the problem is you have to control and you have to protect the environment. If you are not protecting the environment, you are disturbing the ecosystem, means that will affect, may not be directly us, but our future generations. So environmental pollution. So what are the species which are actually causing the environmental pollution and how we can control them, and all the discussions we are going to study in our session. So environmental pollution is the effect of undesirable changes in our surroundings that have harmful effects on plants, animals, and human beings. Like if you look at the overall lifespan of a human being, in the overall lifespan of a human being, how much air we consume, that will be something approximately some 12 to 15 times out of the whatever the amount of food we consume. Okay, an average adult requires 12 to 15 times more air than the food. An average adult requires 12 to 15%, 12 to 15 times more air than the food. That means if we are polluting air, obviously we are polluting our system as well. So pollutant, if you look at any substance which causes pollution, is said to be pollutant. If a substance is causing the pollution, that is said to be pollutant. Pollution means what? Disturbing the ecosystem only. Pollutants can be solid, liquid, or gaseous substances present in greater concentration than in natural abundance and are produced due to human activities or due to natural happenings. Due to human activities means all the industries, all the dangerous gases, whatever releasing. Natural happening means volcanoes, all those things. Yes or no? The pollutants can be solid, liquid, or gaseous substances present in greater concentration than in natural abundance. We require a particular substance, but only in specific quantity, not greater than that, not less than that. That is actually causing the pollution. So pollutants can be solids, liquids, or gases. Biodegradable pollutants. A pollutant can be degraded like discarded vegetables, which rapidly break down by natural process. The vegetables, all of them, they are going to be degradable easily, like paper bags, they are also degraded easily. But if you look at plastics, they are non-degradable. Yes or no? They are not biodegradable. So for the degradation of that particular compound, it requires a lot of time, like decades. Decades itself is not sufficient. So pollutant can be discarded like degradable like discarded vegetables, which rapidly break down by natural process. Vegetable waste. Non-biodegradable means pollutants which are slowly degradable remain in the environment in an unchanged form for many decades. They remain in the environment in the unchanged form for many decades. They are said to be non-biodegradable, like glass waste, non-biodegradable. Pollutant which are slowly degradable remain in the environment unchanged form, non-biodegradable. In that condition, you can also have e-waste, electronic waste, and you can also have the metallic waste. Yes or no? Like iron, metal waste, and you can also have the plastics and all. Yes or no? Plastic. These are all whatever the components I have shown you till now, like the plastics, the metal, the e-waste, like the respective keyboards, yes or no, and also the glasses. They are all non-biodegradable, so they remain in the environment for longer time. Undegradable. That means they ultimately go to the ocean. Majority of them. So they are going to be causing different types of pollution. Aquatic life is affected. All that conditions are going to be there. So we have pollutants. So pollutants are actually classified into solid, liquid, and gaseous pollutants. We'll be discussing about atmospheric pollution. In the atmospheric pollution, we'll study with respect to two perspectives: tropospheric pollution and stratospheric pollution. The lowest region of atmosphere in which the human beings along with other organisms live, that is called as troposphere. Yes or no? The lowest region of atmosphere in which the human beings along with other organisms live, that is called as troposphere. It extends up to the height of 10 km from sea level. From the sea level to 10 km, whatever the region we have, that is said to be troposphere. Above the troposphere, between 10 and 50 kilometers above sea level, we have stratosphere. The stratosphere contains dinitrogen, dioxin, ozone, and little water vapor. Dinitrogen, dioxin, ozone, and the water vapor, these are all present in the stratosphere. The presence of ozone in the stratosphere prevents about 99.5% of the sun's harmful UV radiation. The ozone layer will be protecting from the ozone layer will protect us from the UV radiation. The UV rays are not coming on reaching the Earth's surface because they are stopped by the ozone layer. If the UV layers, if the UV light or the UV rays directly reach the Earth and fall on us, it will be dangerous for us. It may cause skin burning and ultimately skin cancer, and different other diseases can also be raised. Okay, the presence of ozone in the stratosphere prevents about 99.5% of sun's harmful UV radiations from reaching the Earth's surface. We have troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Okay, these are the different types of spheres which were present above the respective Earth surface or above the sea level. And the pollution, environmental pollution, will study with respect to two categories: tropospheric pollution as well as stratospheric pollution. Very good. Atmospheric pollution, with respect to two categories, we will study tropospheric pollution and stratospheric pollution. We will be first starting about tropospheric pollution. Tropospheric pollution again will study with respect to two types of pollutants. Tropospheric pollution occurs due to the presence of undesirable solid or gaseous particles in the air. Tropospheric pollution again will study with respect to gaseous air pollutants and with respect to particulate pollutants. We are studying two types of pollutions, tropospheric pollution and stratospheric pollution. The tropospheric pollution due to gaseous substances, that is gaseous air pollutants. The tropospheric pollution due to particulate pollutants. These are the two things which we are studying. Gaseous air pollutants. Let us start with gaseous air pollutants. So industries release a lot of toxic gases. Yes or no? A lot of toxic gases have been released from the industry. So gaseous substances, whatever they are going to be released, they can be majorly of oxides of sulfur, nitrogen, carbon, and hydrocarbons. Particulates will be like dust, mist, smoke, and fumes. These are nothing but your gaseous pollutants, and dust, mist, smoke, and fume, they are nothing but your particulate pollutants. First, let us study about gaseous pollutants, gaseous air pollutants. The oxides of sulfur in the first category. Oxides of sulfur are produced when sulfur containing fossil fuel is burnt. If we have a fossil fuel which contains sulfur and that is burnt, obviously there is a high tendency for the sulfur to get oxidized to form SO2. That SO2 will be the sulfur dioxide and that will be having different types of effects. Oxides of sulfur are produced when sulfur containing fossil fuels are burnt. Uncatalyzed oxidation of sulfur dioxide is slow. However, the presence of particulate matter in polluted air catalyzes the oxidation of sulfur dioxide to sulfur trioxide also. SO2 will be reacting with O2 to form SO3. 2SO2 plus O2 gives us 2SO3. Yes or no? 2SO2 plus O2 gives us 2SO3. The reaction can also be promoted by ozone and hydrogen peroxide. That means O3 will be reacting with SO2 to form SO3 and O2 can be released. And SO2 can react with H2O2 to form H2S4. O3 is a very good oxidizing agent or reducing agent.
Oxidation.
It will try to oxidize something else or not. O3 is trying to oxidize sulfur dioxide to sulfur trioxide. Sulfur dioxide, sulfur is in +4 state, trioxide in the +6 state. So O3 is oxidizing SO2 means O3 is a very good, is a very powerful oxidizing agent. Powerful oxidizing agent, as O3 will be giving rise to O2 plus nascent oxygen. O3 will be giving O2 plus nascent oxygen. That nascent oxygen will be reacting with SO2 to form SO3. The uncatalyzed oxidation of sulfur dioxide is slow, but the catalysis can be happening in the presence of particulate matter, or ozone and hydrogen peroxide can also catalyze the reaction. Right? Adverse effects of sulfur dioxide. So we are producing sulfur dioxide and that sulfur dioxide can also convert to sulfur dioxide. These oxides of sulfur, they are dangerous, and we look at some adverse effects of sulfur dioxide, SO2. How is this SO2 obtained? The SO2 is obtained majorly by heating the fossil fuel containing the sulfur. Sulfur dioxide is a gas that is poisonous to both animals as well as plants. it causes respiratory diseases in human beings like asthma. First kind of disease which can produce. You have to remember this, the diseases like adverse effects of every gaseous substance. SO2, if we have more SO2 in the atmosphere, that will be causing the respiratory diseases in the human beings like asthma. Bronchitis, how the disease is formed and what was the chemistry inside the particular organ, that is not discussed. Okay, you may ask a question, sir, how the disease came. Asthma, explain the mechanism, what is happening in the asthma. That is completely out of study. There was a chemistry in that also. In every disease also there was some chemistry happening. There is some activity, increased activity or decreased activity, lack of substance or gain of substance or more excess of substance. But all that details we can't study. So we'll just look at the type of adverse effects and all. So asthma, bronchitis, emphysema, yes or no? So these are the different kinds of diseases which are produced whenever you have more SO2. Sulfur dioxide causes irritation to the eyes, resulting in tears and redness. The eyes also becomes red, and it will be also giving the irritation to eyes and resulting in the tears, more tear appearations. High concentration of SO2 leads to stiffness of flower buds, which eventually fall off from plants. For human beings, we have different types of diseases like asthma, bronchitis, emphysema, and also irritation in the eyes and tears. And plants also gets affected. The plants, the flower buds will become stiff and they will ultimately fall down because of the presence of sulfur dioxide. Is that clear or not? Simple logic, the gaseous pollutant, first gaseous pollutant is sulfur dioxide. More is the sulfur dioxide. More the sulfur dioxide. How is sulfur dioxide obtained? By the heating of fossil fuels containing sulfur. The sulfur dioxide can also be catalyzed, converted to SO3. The uncatalyzed reaction is slow, but the catalyzed reaction will be faster. Ozone and H2O2 can also catalyze the reaction because they are good oxidizing agents. And there are different kinds of adverse effects of SO2 like asthma, emphysema, bronchitis, and flowers also going to be affected, irritation in the eyes. So this is the respect to oxides of sulfur, and that is how we are going to be having the environmental pollution. Oxides of nitrogen. So NO, these are also produced. Dinitrogen and dioxin do not react with each other at normal temperature. At high altitudes, when lightning strikes, they combine to form oxides of nitrogen. Like N2 and O2, will they react easily? N2 plus O2 gives rise to NO, 2NO. Is that reaction happening easily? And if you remember thermodynamics, this is also given as an example. Half mole of N2 plus half mole of O2 to form NO. 1 mole of substance has to be formed from its constituent elements from their pure states. That is nothing but enthalpy of formation of NO or not. 1 mole of NO is formed from respect to N2 and O2 from their constituent elements. Enthalpy of formation can be positive or negative. Nandana, is it positive or negative? Enthalpy of formation.
So I think negative.
Okay, anyone else? Enthalpy of combustion. Enthalpy of combustion is always negative. Enthalpy of formation can be negative or positive. Enthalpy of formation can be negative or positive. Mostly it is negative, but for few reactions like this one, N2 plus O2 gives us to NO, it is enthalpy of formation. But here we have to supply energy. So delta H of formation for this reaction is positive, not negative. Because N2 having a triple bond between two nitrogen atoms, O2 has a double bond between two oxygens. We need to provide energy to break the triple bond and double bond, right? So it is going to be positive here. So dinitrogen and dioxin do not react with each other at normal temperature. Why? Because they are already quite stable. Why? Because of triple bond and double bond. At high altitude, when lightning strikes, they combine to form oxides of nitrogen. So whenever lightning strikes, very high temperature will be there. At that condition, N2 and O2 will be reacting with each other to form NO. That is how NO is formed, oxide of nitrogen. That NO will be reacting again with O2 to form NO2. NO2 is oxidized to nitrate ion NO3 minus, which is washed into soil where it is acting as a fertilizer. So we have NO obtained. NO is reacting with O2 to form NO2. To balance the reaction, I need to write 2NO plus O2 gives us 2NO2. NO2 is oxidized to nitrate ion. This is oxidized to NO3 minus nitrate ion. Here we have plus 4 is the oxygen state of nitrogen. In nitrate, we have plus 5. This nitrate ion will be acting as a fertilizer. In an automobile engine, at higher temperature, when fossil fuel is burnt, dinitrogen and dioxin combine to yield significant quantities of NO and NO2. That means what we are trying to say is the nitrogen oxide NO is obtained whenever you try to heat NO, whenever you try to heat N2 and O2, that reaction is going to happen at high temperature. N2 plus O2 gives rise to 2NO at a very high temperature like 1483 Kelvin. NO reacts instantly with oxygen to give NO2. NO reacts instantly with oxygen to give NO2. 2NO plus O2 gives rise to 2NO2. This was the reaction happening. Rate of production of NO2 is faster when nitric oxide reacts with ozone in the stratosphere. Why? In the stratosphere we have ozone, right? Although we are discussing about the tropospheric pollution, but in the stratosphere also we have ozone. In the stratosphere, if we have NO2, if you have NO, that NO react with O3 to form respective NO2. NO plus O3 gives rise to NO2 plus O2. Why it is happening? Why this reaction is happening? NO plus O3 gives rise to NO2 plus O2. That reaction is going to be happening greatly because O3 is a very powerful oxidizing agent. Why? Because in O3 we have a bend structure and repulsions are greater. So whenever O2 is formed, the bond order is going to be 2, which is stronger and stable. That is why the oxygen is going to be easily given by O3. So it is an oxidizing agent. NO plus O3 gives rise to NO2 plus O2. This was a reaction happening easily in the stratosphere as well. And now NO, how we have produced? By the reaction between N2 and O2 at higher temperatures. And like higher temperature can be happening with the help of lightning or very high temperatures obtained in the automobile industry and all. So what are the adverse effects of NO2? The NO, whatever it is formed, it is converting into NO2. And now we will be looking at the adverse effects of NO2 as well. It is also causing respiratory diseases in children. Okay, if you look at the adverse effects of NO2, respiratory diseases in child, the irritant red haze in traffic and congested places is due to oxides of nitrogen. Like whatever the irritation we get whenever we are in traffic and congested places, there you are having some compounds of NO obtained because of the reaction between N2 and O2 at higher temperature. Because of those oxides only, we are getting this irritation in the congested places and all. Higher concentration of NO2 damages leaves of plants and retards the rate of photosynthesis. Okay, that is how the plants are going to become whenever we have high concentration of NO2. Higher concentration of NO2 damages the leaves of plants and retard the rate of photosynthesis as well. It is also a lung irritant. You have to remember these students. What are the adverse effects of NO2? What are the adverse effects of SO2? Like excess of SO2 causes what? Which of the following? Excess of NO2 causes which of the following? Like that questions can be framed. You know how questions from environmental chemistry can be asked.
Yes, sir.
Yes, right. So adverse effects of NO2, that will also be a lung irritant. And then comes the next type of gaseous pollutants or hydrocarbons. Hydrocarbons are compounds of hydrogen and carbon only, and are formed by incomplete combustion of fuel in the automobiles. Like incomplete combustion of fuels, whatever the fuel we have, if that has been the incomplete combustion, under that condition, what you can say? Incomplete combustion will be leading to the incomplete combustion of respective fuels in the automobiles. That will lead to the formation of hydrocarbons, and those hydrocarbons again will be having different types of effects. Those hydrocarbons again will have different kinds of effects. Adverse effects of hydrocarbons. Hydrocarbons are carcinogenic. That means they are cancer causing agents. Hydrocarbons are carcinogenic. That means because of them, cancer can be caused. And what are the other effects of hydrocarbon? Like shedding of leaves, you can say the leaves are going to damaged, the plant leaves. Like skin cancer can be caused because of hydrocarbons if you have excess. They are very dangerous, but still people use the hydrocarbons. We require hydrocarbons to produce energy. Yes or no? Still we require hydrocarbons to produce energy, but they are very dangerous. Shedding of leaves, leaves are going to be damaged. The plants will be damaged and leaves fall down. These are the adverse effects of hydrocarbon. And how are they prepared? They are not prepared, how are they obtained? Like in the incomplete combustion of fuels, the hydrocarbons can be the pollutants which can be produced. After oxides of sulfur, nitrogen and hydrocarbons, we will be looking at the oxides of carbon also. In the oxides of carbon, two oxides we will discuss: carbon monoxide and carbon dioxide. Okay, oxides of carbon, carbon monoxide and carbon dioxide. So let us look at carbon monoxide first. Carbon monoxide is one of the most serious air pollutant. It is a colorless and odorless gas. Yes, Vaidehi. Okay. The smell of petrol, whatever you have, that will be the odor. What you can say, it is not just because of the presence of only benzene, but different other hydrocarbons as well. We have discussed fractional distillation. If you remember, fractions we have separated. Yes or no? Like different fractions are used in different types of conditions. Right? Carbon monoxide is one of the most serious air pollutants. It is a most serious. Carbon monoxide is a very serious air pollutant. It is colorless and odorless gas, highly poisonous to living being because of its ability to block the delivery of oxygen to organs and tissues. So what is the Lewis dot structure of carbon monoxide? Carbon will have 4 electrons, oxygen will be having 6 valence electrons. You try to share 1 electron from carbon and 1 electron from oxygen. Octet, is it satisfied? Not satisfied. 2 electron from carbon, 2 electron from oxygen. Is octet satisfied? Not satisfied. Around carbon we only have 6 electrons. Around oxygen it is 8 electrons are there. You try to share 1 more electron from carbon, 1 more from oxygen. Again octet not satisfied. You try to share 4 electron from carbon, 4 electron from oxygen. Again octet not satisfied. But now what you are going to do is you try to share 2 electron from oxygen only, like a coordinate covalent bond. So we have 2 covalent bonds. One is a coordinate covalent bond, 2 electrons on carbon, 2 electrons on oxygen as well. Now 6 electrons in the sharing part, 6 plus 2 for carbon, that is 8. 6 plus 2 for oxygen, that is 8. So this is how the structure of carbon monoxide can be written, Lewis dot structure. Carbon monoxide is one of the most serious air pollutants. It is a colorless and odorless gas. Carbon monoxide is a most serious air pollutant. It is a colorless and odorless gas because when you look at hemoglobin, the hemoglobin can be, the carbon monoxide can be forming a complex with hemoglobin known as carboxyhemoglobin. The carboxyhemoglobin is a much stable complex. Why? Because carbon monoxide is a strong ligand. Due to the presence of lone pair of electrons on carbon, the lone pair of electron present on carbon, which is a less electronegative element, that is not so stable. So carbon has a greater tendency to donate its lone pair. So it is going to be acting as a very good electron donating agent. That means it is going to be a better ligand. Because it is a better ligand, obviously it is going to form a complex with hemoglobin greatly. So this complex of hemoglobin with carbon monoxide is a much stronger or much stable than the complex of hemoglobin with oxygen. So whenever we inhale carbon monoxide, that complex is going to be formed greatly when compared to the oxyhemoglobin. So that is why ultimately the blocking or the delivery of oxygen to different organs that has been blocked. It is a, you can see the statement, it is a colorless and odorless gas, highly poisonous to living being because of its ability to block the delivery of oxygen to organs and tissues. How? Because of this formation. And that is obtained by incomplete combustion of carbon containing fuels. carbon monoxide is produced as a result of incomplete combustion. We are saying incomplete combustion. Why? Because in carbon monoxide we have carbon in which state? +2 state. But what is the maximum possible oxygen state of carbon? +4. So incomplete combustion happened, not the complete combustion. Incomplete combustion of carbon and carbon containing products like coal, petrol, firewood, they will produce carbon monoxide. Carbon monoxide is mainly released into air by automobile exhaust. Adverse effects of carbon monoxide means they will block the oxygen supply to different organs. Adverse effects of carbon monoxide means they will block the oxygen supply to different organs. It blocks the delivery of oxygen to organs and tissues. It binds to hemoglobin to form carboxyhemoglobin, which is about 300 times more stable than oxygen hemoglobin. Why? Because CO is a strong ligand. Okay, it binds the hemoglobin to form carboxyhemoglobin, which is about 300 times more stable than the oxygen hemoglobin complex. In a blood, when the concentration of carboxyhemoglobin reaches 3 to 4%, if the concentration of carboxyhemoglobin reaches 3 to 4%, the oxygen carrying capacity of blood is greatly reduced. The oxygen carrying capacity of blood, that will be greatly reduced. Next point, effect of oxygen deficiency. Like if there's a deficiency in oxygen, we obviously have different effects like headache, weak eyesight, cardiovascular diseases. Yes or no? So all such kind of diseases you are going to have: headache, weak eyesight, cardiovascular diseases. So these are all going to happen because of the deficiency of oxygen. Oxygen is going to be deficient when we have more, like when we inhale more carbon monoxide, obviously it blocks the oxygen supply. Because of that, we'll be having all these cases. That is about the first oxide of carbon, that is carbon monoxide, and its discussion. Next we have carbon dioxide. Carbon dioxide, if you go with the carbon dioxide gas, is confined to troposphere only. Normally it forms about 0.03% by volume of the atmosphere. 0.03% by volume of the atmosphere, that is your carbon dioxide volume percentage. Carbon dioxide is released into atmosphere by respiration. Yes or no? The carbon dioxide is released into atmosphere by respiration. Like we release out carbon dioxide and we inhale oxygen. And how is it produced? By complete combustion. Burning of fossil fuels for energy, we require electrical energy, right? We always require electrical energy. We have to heat the fossil fuel. We'll be getting the thermal energy. That thermal energy will be converting into respective electrical energy. We have hydropower plants. There we have a different system. We have nuclear power plants. There we have a different system. We are just trying to convert one form of energy into the other form of energy. More and more electricity is used so that the transfer can be easy. You may ask a question, sir, why can't you heat the fossil fuel here only, wherever required, wherever you produce electrical energy? Transfer of electrical energy is simple. Yes or no? And even Tesla, if you remember, the great scientist Tesla, he tried to transfer the electrical energy without wires, like Wi-Fi, like radiation, but that was not came into existence due to different other conspiracy theories. But imagine our lifestyle nowadays, how it would be if the transfer of electrical energy happened without any wires. There were people who used to make different comments like, no, we'll be getting the current shock and all, because how that can be possible. But many things which were found to be impossible earlier, we are using them. Like mobile phone, simple example. Yes or no? So which found to be impossible earlier, we are using now. So that might be happening in the future. Tesla had a plan, but because of different other reasons, that was not happened. Carbon dioxide is released into atmosphere even in the decomposition of limestone during the manufacture of cement. CaCO3, whenever you heat limestone, you will be generating CaO plus CO2. So there are different sources from which carbon dioxide can be obtained. But carbon dioxide, if its concentration is greater than 0.03%, or if it is concentration increasing, it will again lead to different other problems. Okay. Carbon dioxide is released into atmosphere by the volcanic eruptions as well. Like these are the different ways from which carbon dioxide can be obtained. The main problem of carbon dioxide is going to be it is responsible for global warming. About 75% of solar energy reaching the earth is absorbed by earth's surface. So we have earth. This is earth's surface. Here we have some sun. From that we are getting the solar energy. 75% is absorbed. Remaining 25% is emitted back. If it's a black body, how much is absorbed, how much is emitted back? Black body is a perfect absorber and a perfect emitter. Yes or no? Yes. About 75% of solar energy reaching the earth is absorbed by earth's surface, which increases its temperature, because earth is actually absorbing the solar energy and 75% is absorbing and 25% is emptying out. If you think carefully, the rest of the heat radiates back to the atmosphere. Some of the heat is trapped by gases such as carbon dioxide, methane, ozone, chlorofluorocarbon CFCs, and water vapor in the atmosphere. Some of the heat is trapped by gases such as carbon dioxide, methane, ozone, CFCs, and water vapor in the atmosphere. Thus, they add to the heating. That means they will be trying to trap that particular heat. Ultimately, they will be responsible for the increasing temperature, and thus it will be responsible for global warming. So if the concentration of CO2 has been increased, obviously what is going to happen? More heat is going to be trapped. If more heat is trapped, obviously more will be the temperature. If more is the temperature, the glaciers are going to melt down. Ultimately, you will be having the global warming. And this is how the gas is going to look like. Yes or no? Like with the increased temperature, what kind of effects we are going to have is very high. So this is how the scenario. The ozone layer is actually protecting us. Troposphere and stratosphere. From the stratosphere, the UV rays, they are not coming because of the ozone layer protection. Okay, sun's rays are coming down and 75% absorbed and remaining rays are reflected back. And in the process of reflecting back, if you observe carefully, the radiation which was supposed to reflect back, that is actually trapped within these molecules or not. Chlorofluorocarbons, carbon dioxide, H2O. These are holding it back, CH4, methane, water vapor. So they are going to increase the temperature because they hold the radiation. Yes or no?
Yes, sir.
But now the question is, you give me any molecule, I'll draw the shape of that molecule in such a way such that the radiation is trapped. If you give benzene also, like benzene I'll draw here. Another benzene I'll draw here. Another benzene I'll draw here. Another benzene I'll draw here. And I'll call some radiation has been trapped. Is that true? Like any molecule, you toluene, you give O2, you give any molecule, we can draw such like that, like CO2, how they have drawn C double bond O, C double bond O, C double bond O, C double bond O. Radiation has been trapped. I will draw any molecule randomly in the space, and I can also say radiation has been trapped. But is that possible for every molecule to be trapping the radiation? So it's not about figures what they are drawing here. You be careful. It's not like CO2 drawn in the shape of triangle and in between I can keep a radiation. I can draw CH4 and keep a radiation in between two CH bonds. I can draw two H2O in the two V shapes and I can keep a radiation. That's not the idea. You should ask a question, sir, why only CO2, why only CFC is actually holding the radiation? Why can't any other gas molecule? Why is that happening? Yes or no? The trapped rays, whatever the trapped rays we have, they are going to increase the temperature. So why only specific kind of gaseous substances they are trapping the radiation? Why can't every other substance? You know this, right? From the school level you have studied. CO2 is going to trap the radiation and it will increase the temperature, thereby causing the global warming, thereby having different effects. Yes or no?
Yes, sir.
Yes.
Why the why only CO2 or why only CFC? Why only specific gases hold? If you think of this question, you have to think of vibrational frequencies. Wherever the vibrational frequencies are matching with the respect to, like whatever the radiation we are saying, it will be having a specific frequency. Whenever the frequencies are going to match, then only the heat can be trapped. Not like drawing the molecules in any shape. Every bond, I have told you, bond is not a static scenario. It will be always having some, like two spring mass systems you can consider. Two masses connected to the spring mass system, that is nothing but your bond. So you have to imagine the bond as a spring mass system, and every bond will be having the vibrational frequency. Whenever the vibrational frequencies of the covalent bonds present in the different molecules, when they are in resonance with the respective heat radiations, then only that can be holded back. And that is why only specific type of gases are going to be present as your gases. They are going to be acting as a respective holding substances for the radiation, whatever it is going to be reflecting back. Not every gas is going to be holding the radiation. And this is a just basic way to say vibration frequencies. A lot more things we have to study in that perspective. So we have the same greenhouse effect in the countries like Canada, where the temperature falls below 0 degrees Celsius frequently. So there you have to do some vegetation and do some farming, in the sense the plants require some temperature also. So under that condition, we'll do the farming in such kind of setting, which is producing the same greenhouse effect. So whatever the sun's radiation coming and hitting, they are trapped inside this particular greenhouse, and thus the temperature inside this will be high, and that is sufficient for the growth of plants. The atmosphere has kept the temperature on Earth constant, as a glass is a greenhouse. As the glass in a greenhouse holds the sun's warmth inside, atmosphere traps the sun's heat near the Earth's surface and keeps it warm. This is called as a natural greenhouse effect. So wherever you have to do the farming and all in the regions of very low temperatures, where the respective growth of a plant is going to happen only at a specific high temperature, then you have to do that farming in the respective greenhouses. The same is happening in our atmosphere also. Factors responsible for global warming. First one is DDT. DDT mechanism we have discussed. If you remember, we have discussed the mechanistic approach of DDT or not? Yes or no?
Sir.
Dichloro, diphenyl trichloroethane, CCl3CHO, H2SO4. And from that mechanistic approach, we have seen the electrophilic substitution reaction happening at the para position attack is happening. DDT's vehicles, the gases released out from the vehicles. So factors responsible for global warming, deforestation, DDT, all those uses, burning of a non-biodegradable waste. This is also causing a lot of issue. You may think like, sir, you are saying non-biodegradable waste are there, plastics and all. I can simply heat it, then they are lost. But if you heat it again, they are going to produce gases which are going to affect the environment in the other way. You are not removing the problem, you are just transferring the problem from one way to the other way. Okay, non-biodegradable waste, if you are heating it, you are not removing that waste, you are not removing the problem, you are creating a new problem, because gases, dangerous gases are obtained. So burning of non-biodegradable waste is also a leading problem or leading cause for global warming. Then comes the acid rain. Normally rainwater has a pH of 5.6 due to the presence of H+ ions formed by the reaction of rainwater with carbon dioxide. Because we have water, H2O, and we have carbon dioxide. This carbon dioxide dissolves in the water to form H2CO3. H2CO3 carbonic acid is a weak acid which has a dissociation. Two dissociations are there. It produces 2H+ and CO3 2- ion. like if you look at the first dissociation, it forms H plus and HCO3 minus ion, and HCO3 minus again dissociates to form H plus and CO3 2 minus ion. Okay, this was the dissociation constants K1 and K2. So due to the presence of H2CO3, which is formed by the dissolution of gas in a liquid, so you are having more H2CO3. Because of that H2CO3, you are having the pH of rainwater to be somewhere around 5.6. Normally, rainwater has a pH of 5.6 due to the presence of H plus ions formed by the reaction of acid water, rainwater with carbon dioxide present in atmosphere. The gas dissolved in water to form H2CO3, which was acidic in nature. Because of that, pH is not 7, it is less than 7. If the pH of rainwater is 5.6, if the 5.6 pH is again reduced, then it is said to be acidic rain. H2O plus CO2 gives us to H2CO3. H2CO3 gives H plus and HCO3 minus ions. When the pH of rainwater drops below 5.6, up to 5.6, it is due to H2CO3. But if the pH of the rainwater falls below 5.6, it is said to be acid rain. Burning of fossil fuels, which contain sulfur and nitrogenous matter, such as coal and oil in power stations and furnaces, or petrol and diesel in motor engines, produce sulfur dioxide and nitrogen oxides. SO2 and NO2 after oxidation and reaction with water, they are the major contributors to acid rain. That means you may ask a question, sir, why are you only dissolving the CO2 to produce H2CO3? Why can't you dissolve SO2 and NO2 to form H2SO3 and HNO3? That is also a valid question or not? So SO2 can also react with oxygen. The dissolution of gas in H2O can happen to form H2SO4. NO2 can also dissolve in the water to form HNO3, but their concentrations are less when compared to CO2. But whenever these concentrations are also greater by heating of fossil fuels, then you will be generating H2SO4 and HNO3, which are even more acidic. Whenever SO2 and NO2 are great in the atmosphere, they will produce more H2SO4 and more HNO3. They will dissolve in the water. Like they will be having more H plus ions. They are responsible for the acidic rain. Acidic rains will have pH of less than 5.6. pH of rainwater is 5.6. pH of acid rain is less than 5.6. Acid rain will be having different other effects. Adverse effects of acid rain. First effect which you can think is corrosion. Acid rain is harmful for agriculture, trees, plants, as it dissolves and washes away nutrients needed for their growth. As it dissolves and washes away nutrients needed for their growth. Yellowing of plant leaves is also because of acid rain. And Taj Mahal, okay, like near the Taj Mahal in the Agra region, we'll be having many industries. Because of the lot of industries, we'll be having more SO2 and more NO2. Because of that, the acidic rain is happening. Because of acidic rain, this monument has been changing its color. Yes or no? The Taj Mahal is actually affected by acid rain only. Weathering of stone buildings. The Taj Mahal in India has been affected by acid rains. Adverse effect of acid rain is corrosion. Yes or no? Due to corrosion, because of corrosion also, lot of damage, like hundreds of crores we are losing every year because of corrosion, if you know. What is corrosion? Corrosion of metallic structures. Adverse effect of acid rain is aquatic life will be dead. Killing of aquatic life form because of increased concentration of H plus. Can anyone say what is corrosion?
Rust formation.
Oxidization.
Yeah, what was the mechanistic approach I'm asking? Yeah, rusting of iron is corrosion. That is the basic concept. But what is the mechanistic approach? Yes, Ihina?
So the metal gets oxidized.
Yeah, how is that? Okay, let us look at the mechanistic approach of corrosion. I'll explain it briefly regarding the rusting of iron. The same question I'll ask whenever we study the respective electrochemistry. Next chapter will be electrochemistry. In that we have the corrosion and all. If you take iron, in the metallic structure of iron, one part or one spot of the iron rod will be acting as an anode, where the iron will be converting into respect to Fe+2 and electrons are going to be lost. One spot of the iron, like this part and this part, acts as anode. This is Fe, this is Fe. They will release the 2 electron. This Fe will also release the 2 electron. As soon as it releases the 2 electrons, it will be converting the Fe+2 also. It will also form Fe+2. It will also form Fe+2. The electrons which were released by the oxidation of iron rod, they will be traveling through the metal lasses. These electrons will reach the other spots, where we have oxygen. Oxygen is obtained from the atmosphere. From atmosphere we have oxygen, and we have electrons, like 4 electrons we can take. And we also have H plus ions, 4H plus 4 electron plus O2 will be forming respective H2O. How much H2O? 2 H2O. For this we have electrode potential E0, like 0.44. For this also we have electrode potential plus 1.73, like that. The electrode potential values will give. So Fe, like in the iron rod, if I take this as the iron rod, at one spot iron is undergoing oxidation. It is producing the electrons and Fe+2 ions. These electrons are traveling to the metal. At the other spot, those electrons will be reduced, that is the oxygen will be reduced. O2 will take up the electrons in the presence of H plus ions. O2 is present from atmosphere. Electrons obtained from the oxidation of Fe. From where we get H plus ions? From H2CO3. H2CO3 is obtained by the dissolution of CO2 in H2O. Dissolution of carbon dioxide in water will happen. Because of that, we produce H2CO3. Because of the H2CO3 formation, we get the H plus ions. I am saying just because of H2CO3, we are getting H plus here. But if we have acidic rain, we will be having H2SO4 as well as HNO3. So more H plus are there. In the presence of more H plus, obviously more fastly this reaction is going to happen. Now because of oxygen, what happened? Because of oxygen undergoing the conversion, what happened? At this particular point, you form water. H2O has been formed. And we also have Fe+2. This is the first oxidation, reduction. The third one is further oxidation of Fe+2. The Fe+2 ions will be again further oxidized in the presence of water, which is formed to form Fe+3. This Fe+3, the oxide of Fe+3 is Fe2O3 in the hydrated form. Fe2O3 in the hydrated form is nothing but rust. In the conversion of Fe+2 to H2O in the presence of oxygen, we again release H plus ions. Those H plus will again be initiating the second step. Everyone understood the mechanistic approach of corrosion or not? At one point of the metal, iron will be converting into Fe+2 and electrons are released. Those electrons reach the other point where oxygen is there at the other point, because from the atmosphere we have oxygen. We have H plus ions from the acidic medium, because carbon dioxide from the atmosphere dissolved in water to form H2CO3. H2CO3 is an acid which has H plus ions. O2 plus 4 electron plus 4H plus gives 2H2O. This Fe+2 which is present, that will again oxidize in the presence of H2O to form Fe+3, and that will also produce H plus. So this Fe+3 in the oxide of iron, the hydrated oxide of iron is nothing but rust. Fe2O3.XH2O is nothing but rust, and this Fe2O3.XH2O, that rust formation will be more whenever we have more H2O. Yes or no? Because in the presence of water only Fe+2 dissolution. When we have more H2O, whenever this reduction occurs greatly, when we have reduction occurs greatly, whenever we have more H plus. So can I say in the acidic rain, we also have H2SO4, HNO3, because of that H plus concentration is great. Because of acidic rain, more H plus ions are there. More is the conversion of O2 to water. More is the conversion of Fe+2 to Fe+3. That is, more is the rust formation. Is that clear or not?
Yes, sir. Yes, sir.
Okay, that was the mechanistic approach of rust formation. You may ask different types of questions. Sir, why is this mechanism spontaneous or non-spontaneous? Rusting of iron, is it spontaneous or non-spontaneous? To understand the rusting of iron, to understand spontaneity, what we have to look at? You have to look at delta G. Delta G has to be is equals to minus NFE. How we can say this delta G is equal to minus NFE? What is delta G? Like work done due to the electrical work done due to the electricity, that is due to charge. That is nothing but charge into potential. How much charge is actually transferred? Let us say work is done because of the some charge like N Faraday. Potential is E. So work done will be decreasing in the Gibbs free energy. Work done is nothing but decrease in free energy. Decrease in free energy. The decrease in free energy is equals to NFE. Decrease in free energy is minus delta G, that is equals to NFE. Minus delta G is equal to NFE means delta G is equals to minus NFE. Delta G is equal to minus NFE. Delta G has to be negative for spontaneity. Delta G has to be negative means what should be E? E should be positive. Delta G has to be negative means E should be positive. So the electrode potential of this cell, since it is positive, since the electrode potential is positive, delta G is negative. Delta G negative means it is going to be spontaneous. Again, you may ask a question, sir, how do you know electrode potential is positive? Electrode potential value, how we are saying this much and they are positive. That I am not saying. That is depending upon hydration enthalpies, crystal lattice structures, and ionization energy 1, ionization energy 2 all. Okay. From the hydration enthalpies, from the heat of atomizations, from the sum of ionization energies only we can comment on electrode potential. Based on the crystal lattice structures only, ultimately all these electrode potential depends. Okay.
Yes, sir.
Although it seems environmentalist chemistry is simple, but if you go into details of every reaction, everything, it would be interesting and logical as well. Since corrosion is useful in electrochemistry also, I have discussed its mechanistic approach. So these are the different pollutants. So far we have discussed gaseous pollutants, SO2, NO2, NO, hydrocarbons, CO, carbon monoxide, carbon dioxide, global warming, acid rain. Then the next kind of tropospheric pollution is due to particulate pollutants, gaseous air pollutants and particulate pollutants. In the particulate pollutants, we have smoke, dust, mist, and fumes, different categories. We'll study them. Particulate pollutants are minute solid particles present in vehicle emission, smoke particles from fire, dust particles, and ash from industries. Solid particles present in vehicle emission, smoke particles from fires, dust particles, and ash from the industries. Particulate pollutants are actually two categories, viable and non-viable. Viable means what? The viable particulates, example, bacteria, fungi, molds, algae, are minute living organisms. They are living organisms that are dispersed in atmosphere. In the atmosphere, we have a lot of bacteria, a lot of fungi, but all of them are not dangerous. Some are dangerous, some are deadly. The viable particulates, example, bacteria, fungi, molds, algae, are minute living organisms that are dispersed in atmosphere. Human beings are allergic to some of the fungi found in air. They also cause plant diseases. Bacteria, fungi, molds, algae. Yes or no? All these are different viable particulate pollutants. Viable means which have life. Non-viable particulates may be classified according to nature and size as follows: smoke, dust, mists, and fumes. These are all the non-viable particulate pollutants. So let us understand about what is smoke and what are the different definitions of all the non-viable particles, like how are they formed and all. If you look at smoke particulates consist of solid or mixture of solid and liquid particles formed during combustion of organic matter. Solid or mixture of solid and liquid particles. Smoke particulates consist of solid or mixture of solid and liquid particles. And how are they formed during the combustion of organic matter? Examples, you can say cigarette smoke, smoke from burning of fossil fuel, garbage and dry leaves, oil smoke. All these are the cases from where you will be getting the respective smoke. Yes or no? And it is also dangerous particulate pollutant. Dust. Dust is composed of fine solid particles over 1 micrometer in diameter. Earlier smoke we can have solid or solid and liquid particles, but now dust means of fine solid particles over 1 micrometer in diameter produced during crushing, grinding and attribution of solid materials. Sand from sand blasting, sawdust from woodworks. We can see the woodworks whenever you're doing, you will have a lot of dust. Yes or no? Sawdust from the woodworks, pulverized coal, cement and fly ash from factories, dust storms. All these are the typical examples of particulate pollutant where the particulate pollutant is dust. Whenever you have seen the wood cutting, you can see a lot of dust coming out. Yes or no? These are the different examples of dust, and the particulate size should be over, that is greater than 1 micrometer in size, in diameter. Next, mists. Mists are produced by particles of spray liquids or by condensation of vapors in air. Liquid sprays, whenever you have, those can form mists, or condensation of vapors in the air. The vapor will be present, right? That will be again condensed back into the liquid. So they are forming the mists. Examples of sulfuric acid mist and herbicides and insecticides that miss their targets and travel through air and they form mists. Like if you see the herbicides and insecticides that are used in the farming land, so some of them are going to be missing the respective target and they will be traveling through the air and they form mists. They will be forming respective mists. Mists are produced by particles of spray liquids. Smoke means solid particles or solid and liquid particles. Dust means solid particles only where the diameter is greater than 1 micrometer. Mist means a liquid space or by condensation of vapors in air. And then we have fumes. Fumes are generally obtained by condensation of vapors during sublimation, distillation, boiling. We will be doing all these techniques like sublimation, distillation, boiling, and several other chemical reactions. Generally, organic solvents, metals, and metal oxides form the fume particles. They are obtained in industry waste, generally fumes. Wherever you have the sublimation or distillation plants, there you will be having generally more mist formation, more fumes formation. The fume particles are going to be formed near such cases where the condensation of vapors are going to be happening. Is that clear, students, so far?
Sir.
Yes or no? All these are very simple. Okay, whenever you compare the previous topics, these are very easy and you can score everything. As I was saying, you will not be missing a single question from these topics. Lead is a major air pollutant. Lead used to be a major air pollutant emitted by vehicles. Like leaded petrol used to be primary source of airborne lead emission in Indian cities. Earlier we used to use the petrol which is containing some lead and that will be having a lot of air pollution. This problem has now been overcome by using unleaded petrol in most of the cities in India. Lead interferes with the development and maturation of red blood cells. The lead is going to be interfering with the development and maturation of red blood cells, and that is how it is going to be affecting the total scenario. And we have two types of particulate substance as well. Until now we have discussed about smoke, dust, mists and fumes. The smoke and the fog, whenever they combine, they form smog. What is smog? Smog means smoke plus fog. Smoke, whenever it is combining with fog, it is called as smog. This smog can be classical smog as well as photochemical smog. The word smog is derived from smoke and fog. This is the most common example of air pollution that occurs in many cities throughout the world. The smog is actually classified in two types, classical smog and photochemical smog. The word smog is derived from smoke and fog. Okay, it can be again two categories, classical smog as well as photochemical smog. Smog is actually classified in two types, classical smog and photochemical smog. What is classical smog? Classical smog is an example or a mixture of smoke, fog, which one is called as a among classical smog and photochemical smog? Classical smog is said to be reducing smog because it has oxides of sulfur, that is sulfur dioxide, which can undergo further oxidation. Something which is undergoing further oxidation is said to be a reducing mixture. Yes or no? And photochemical smog is called as oxidizing smog. So let us look at a classical smog and photochemical smog. Classical smog is a mixture of smoke, fog, and sulfur dioxide. Generally, smog is nothing but smoke and fog. Along with smoke and fog, if you have sulfur dioxide, it is said to be classical smog, and chemically it is a reducing mixture. It is also called as reducing smog. Why? Because sulfur dioxide itself will be acting as a reducing agent. Chemically, it is a reducing mixture, so it is called as a reducing smog. Photochemical smog. The main components of photochemical smog results from the action of sunlight on unsaturated hydrocarbons. The main components of photochemical smog, how are they obtained? They are obtained by the action of sunlight on unsaturated hydrocarbon and nitrogen oxides produced by automobiles and nitrogens. Photochemical smog contains a high concentration of oxidizing agents, and therefore it is called as oxidizing smog. Why it is called as oxidizing smog? Why it is called as oxidizing smog? Because it contains the oxidizing agents high concentrations, and that is why the name oxidizing smog has been given to it. Okay. The main components of photochemical smog results from the action of sunlight on unsaturated hydrocarbons and nitrogen oxides produced from automobiles. This you have to remember. So unsaturated hydrocarbon CXH5 unsaturated and NO. So O2 plus O reacts with O3, reacts with each other to form O3. That O3 will be easily catalyzing the NO to NO2 conversion. Ozone is toxic gas, and both NO2 and O3 are strong oxidizing agents and can react with unburnt hydrocarbons in polluted air to get chemicals such as formaldehyde, acrolein, and peroxyacetyl nitrate PON. PON in polymer chemistry, what do you call PON in polymer chemistry? Yes, Pavani, what do you call PON in polymer chemistry? Polyacrylonitrile. Yes or no? That is different. And here PON is peroxyacetyl nitrate. This is different. So what happens? CH4, the hydrocarbon reacting with O3 to form HC double bond OH plus 3H2O. So acrolein and a CH3 C double bond O. CH3 C double bond O NO2. This is nothing but your peroxyacetyl nitrate. Ozone is toxic, and both NO2 and O3 are strong oxidizing agents and can react with unburnt hydrocarbons in polluted air to produce chemicals such as formaldehyde, acrolein, and peroxyacetyl nitrate, that is PON. And these are the chemicals which are obtained from the respective photochemical smog. Yes or no? Because ozone is also produced. These are the components present in the, or these are the chemical components which are produced in the photochemical smog. You can treat them in that way. Effect of photochemical smog. Both ozone and PON, peroxyacetyl nitrate, they are powerful eye irritants. They cause irritation to the eyes. Ozone and nitric oxide, they will irritate the nose and throat. Ozone and nitric oxide, they will cause the irritation in the nose as well as the throat. High concentration of ozone and nitric oxide causes headache, chest pain, dryness of the throat, cough, and difficulty in breathing. Like these are the different difficulties with respect to different types of photochemical smog, like different types of diseases which are obtained because of the photochemical smog. And there are something called as catalytic converters also. Headache, difficulty in breathing, chest pain, all these are the results of photochemical smog. Photochemical smog leads to crackling of rubber and extensive damage to the plant life also. It also causes corrosion of metals, stones, building materials, rubber, and painted surfaces. A lot of things. The photochemical smog, which is containing unsaturated hydrocarbons and oxides of nitrogen, it will be having a lot of adverse effects. Okay. So corrosion of metals, stones, building materials, all those are going to happen because of this respective photochemical smog. So now how can photochemical smog be controlled? How can we control the photochemical smog? Like how the photochemical smog, what is responsible for photochemical smog? It is the nitrogen oxide, oxides of nitrogen and hydrocarbon. So they are going to be reacting, right? So these catalytic converters are some species which are used in the automobiles, which prevent the release of nitrogen oxide and hydrocarbon to atmosphere. They won't be releasing the nitrogen oxide and hydrocarbons. This is what catalytic converters means. Catalytic converters are used in the automobiles, which prevent the release of nitrogen oxide and hydrocarbon to the atmosphere. Like you have, this is a catalytic converter. If you look at the working of the catalytic converter, so inside that you will be having this type of substance: exhaust, carbon monoxide, hydrocarbons, oxides of nitrogen. Emission is water, H2O, vapor, N2, nitrogen. So like that, the catalysis is going to happen. And precious metals you have to take where the catalysis is going to happen. The oxidation of carbon monoxide to respect to carbon dioxide, C2H4, ethene to respect to CO2. That CO can be reacting with NOx, oxides of nitrogen to CO2. These are the reactions happening. Everyone got these reactions or not? The carbon monoxide, the oxides of unsaturated hydrocarbons and oxides of nitrogen, they are dangerous. They are contributing to photochemical smog. So if every vehicle is releasing out the photochemical smog, it is affecting the environment greatly. So that is why we have to use catalytic converters. These catalytic converters will convert the respective hydrocarbons, oxides of nitrogen to carbon dioxide. Because of that conversion, what is going to happen? Because of that conversion, the photochemical smog is not formed, and ultimately the damage has been rescued or stopped. Yes or no?
Yes, sir.
So this is the catalytic converters way. And how can photochemical smogs be controlled? In that category, the first one is photochemical smog can be controlled with the use of catalytic converters. The second category is there are certain kinds of plants like pinus, juniperus, quercus, pyrus, and vitius. They can metabolize the nitrogen oxides. They can actually metabolize the nitrogen oxide, and thus NO can be metabolized, means obviously it is not released to the atmosphere. So you can just do plantation of such kind of plants. That will also be causing that will also help us in actually decreasing the concentration of NO in the atmosphere, thereby controlling the photochemical smog and thereby saving us from the different kinds of pollutions or different kinds of effects. These are those plants, and these plants, how much we can plant. Yes or no? That is why catalytic converters also has a major role, and we don't know about their growth and all. They can be grown where under different areas or not. All that is again a different issue, because throughout the world we can't do the plantation of such plants because the temperature conditions also have the effect. Yes or no? So this is
Yes,
nothing but
sir.
your respective tropospheric pollution. Next kind of pollution is stratospheric pollution. We'll discuss that in next class. So, but what is tropospheric pollution? Like we all live, human beings, along with many other organisms, live in troposphere. Two types of pollutants: gaseous pollutants and particulate pollutants. Gaseous pollutants: oxides of sulfur, nitrogen, hydrocarbons, oxides of carbon, global warming, acid rain. And particulate pollutants: viable, non-viable, bacteria, fungi, all viable. Non-viable means smoke, dust, mists, as well as fumes. And smoke and fog will be also called as smog. Classical smog, photochemical smog. Classical smog, why it is called different categories, like reducing smog, oxidizing fog is photochemical smog, and how the adverse effects are there for photochemical smog and how that can be controlled. All those points we have studied. So you have to read this daily. If not, you will remember, you will forget everything. So to remember and answer correctly, you have to read. So keep a target like these 4 chapters, starting from biomolecules to environmental chemistry. You treat this as one set. Whenever, like every week, you have to revise them once. You will never forget. Like P block, S block, there also you have something to remember, but there's a chemistry more involved there when compared to the chemistry which we are studying in this environmental chemistry chapter. Right? Thank you all, everyone. Bye.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.